Louder. Louder? Here's good? Great. So, first of all, thank you very much for having me. So I originally, well, I gave a version of this at B-Sides Glasgow. Since then, a few things have changed with the Nemesis project that I'll talk about later. But first of all, a little bit about me, because I'm not really anyone important. So I'm currently a security consultant at NCC for like the next few days. I was working on, before I was at NCC, I was working on my PhD in applying some learning type things to cryptography problems. But I ended up dropping out of that because I didn't really want to be an academic, and the work I was doing, you'll see later, it's interesting, but it has basically no practical relevance whatsoever, and I'd rather do something that made a difference in the real world, right? So I used to be a software engineer. I was a Java drone for a couple of years. I did a little bit of blue team work for the university I was studying at. So I've had a bit of a weird route into InfoSec, but then I guess who hasn't? So in terms of things I'm going to talk about, what is machine learning is the topic of a like 12-week university course. I'm going to give like a really brief overview of some of the things that machine learning has and the things that it involves. Talk a little bit about what it can do, how it works, and also how you guys can do the thing if you want to. First of all, what is machine learning? It's not like magic. It's not like a fix for everything. And it's not like, when I say it's not fairy dust, what I mean is you can't just like sprinkle some machine learning on a project to try and get the result that you want. Some problems are really good for machine learning, like applications. And what you want to do there is you want to build around the machine learning technique that you're doing. You can't just like bolt on at the end. It's not the kind of thing that you put into your like last sprint on a software engineering project, build the neural network that powers the whole thing. Anyway, that's a lot about what it's not. In terms of what it is, machine learning is basically artificial intelligence, like as a rule. You have data that you have a model which you use for interpreting the data that you're gathering. You have a method for altering the model based on the data that you've got. So that's the learning part of machine learning. And once you have your model, and once you've trained it based on the data that you've got, you then need like other data to actually use it. What you're doing is you're building a tool which you can then apply to other things. In terms of flavors, so when I say that machine learning is artificial intelligence, it's broadly true. And even within artificial intelligence, there's a whole lot of various related stuff that fits into machine learning. In terms of the stuff that I'm going to talk about today, we have neural networks, genetic algorithms as a thing. I'm going to talk a little bit about rule-based systems, but not too deep into it, because in terms of like what's really popular at the moment, it's this neural network stuff is like what everyone's talking about. In terms of what kind of type of machine learning you should care about, and I realize that I'm going really quickly in this. I've barely told you what machine learning is. I've told you that there's like a million different flavors of it, and now I'm saying among these million flavors, how do you pick the one that you actually want? It's heavily problem dependent is the issue. And so I used to do research in this area. I've tried to keep relatively up to date, but I'm not a machine learning expert, caveat. These two people are, and you should definitely read their book, Machine Learning and Security, if you're interested in like properly pursuing this. As far as I'm aware, though, there are no definite rules for picking what kind of machine learning technique you should use for a particular problem. People go based on what seems to have worked in the past. I can't quite express just how new this whole field is. I mean, computer science as a discipline has only existed for, what, the last 80 years, roughly? Maybe a little bit longer. This stuff is new even in a remarkably new field. So still trying to work out even the kinks. People are trying to figure out like what words mean. So genetic algorithms are a really interesting thing to kind of like get started with. And it also helps illustrate a bunch of interesting problems as far as machine learning is concerned. First one is, like I talked about neural networks and genetic algorithms. So two things that they have in common is that they use biology terms that are wildly inaccurate. Like genetic algorithms are to actual genetics as like hot dogs are to canines. It's, a good way of describing it is like deathmatch but with programs. So what you do is you generate a program to solve a particular problem. You generate like a million other different programs to also solve that problem. You give it some, you test it to see how well it actually solves the problem that you care about. As long as you can quantify how good a solution it is, because that's the main thing, what you can do is you can then pick the best ones and either like tweak them slightly or combine them or maybe combine a bunch of them together or put them into like a second round of deathmatch. You pick out the best ones, you generate a bunch of random new ones, and that forms your second generation. And you keep doing that until either you found a program that perfectly solves your problem, which is unlikely, or you find one that's good enough, because you can measure how good it is at tackling your particular problem, or you run out of evolutions, or your AWS account goes bankrupt, or whatever. That didn't quite happen to me, but during my PhD research, I did have like an AWS machine, and it accidentally got renewed for an extra year just after I quit. That was a little bit embarrassing. Anyway, so you pick the good ones to go through the next round, you eliminate the bad ones, and you gradually approach a good solution, in theory. This is that you have your winners of your last round plus the babies, or babbies. You either mutate the winners or you combine some of them together, add some random ones too because diversity is good. Stop point and threshold of goodness is reached. Diversity is important to the remainder of this talk. Or you have like a set number of generations. Robot codebreakers. So this is the PhD work I was doing. You have, so my frustration with academia at the time was born out of the start of my project. So I was wondering, can you use genetic algorithms to attack crypto? And by crypto I mean cryptography, not this weird like billions of GPUs playing number wang thing that's going on at the moment. Controversial maybe. And so what people were doing was they were guessing keys. They had a crypto system. They guess a key. Is the key good? Like, does it produce a decryption that's similar to what we're expecting? If so, keep it and like tweak it and gradually maybe find it. Problem is, that is doomed to failure. Maybe that's a bit of a blanket statement. No one has ever succeeded, is maybe a little bit better. And the reason why is because the way ciphers are designed is that you pick a key. You don't want similar keys to produce similar results, because that means your crypto is like profoundly broken. And this genetic algorithm stuff, it's all search-based. And there's no gradient on the search space for you to exploit to gradually home in on a correct solution. So instead what I did was, all right, we know how a bunch of different ways of attacking modern crypto systems work, right? We have a bunch of techniques. Let's build a language where you can express those different techniques. So we have the plain text, we have the input to the final round, we have the ciphertext, and we have the key. We have a bunch of different ways of combining those things. By key, I mean key guess, like your guessed version of the key. What you do is you generate statements that involve these units, and then you see how good they are at like differentiating between you guessed the key correctly, or this part of a key correctly, and you guessed it wrong. and then you profit, or you publish a paper, or whatever passes for like success in the academic world. And we kind of got it. Like, this is a little bit of a weird thing, but long story short, the bit at index 12716 modulo 16 of the plaintext is equal to the 0th bit of the input to the final round. This is a linear approximation for any of you who know what linear cryptanalysis is. And the upshot of linear cryptanalysis is you have a statement that links these 2 points in the process, you guess your key, you shove the ciphertext backwards through the cipher, and then see whether that relationship holds. And if that relationship holds with a bias, like more than random chance, your key guess is correct, or partially correct. And so yeah, this is a genetic algorithm producing a useful result. And if you didn't know what linear cryptanalysis was, this genetic algorithm just told you. It rediscovered linear cryptanalysis, given just random data and no preconceptions. Great. What did it discover with this statement? I don't know. That is not a thing a human can process. And this is a huge problem with machine learning. It's called the semantic gap. And what that is the difference between a model that has some kind of representation of the world, like what cars look like, or what packets are offensive. And by offensive, I mean like the kind of things that people like me produce, rather than anything else. And the answer is, you might be able to build a model that works reasonably, but in terms of like actually extracting useful information from that model, as opposed to just a black box you can throw stuff into and get it piped into different compartments, it's really difficult. And there are a few people I know who are working on related stuff to hopefully make that a little bit better, but it involves maths I really don't understand. Neural networks. So this is the kind of like approach du jour. It's like, it's fashionable at the moment. And this is a really simple version, because neural networks come in about as many different flavors as machine learning does. But this kind of neural network is relatively straightforward. You have your input nodes, which you feed a bit. Each node gets a bit. It interprets that and decides whether or not to fire. And if it fires, it transmits a signal down its connections. These inner nodes receive a bunch of different signals. Based on the signals they receive, they decide whether or not to fire, and so on until you get to the output nodes. And then like the combined signal from those output nodes is your classification. So say you have, you have 2 output nodes here, which means you can represent 4 different answers, if that makes sense, because it's just binary. That means it can sort your input, which can consist of like 2 to the 3 different inputs, into 2 to the 4 different boxes. Some neural networks will just have like 1 output node. It's like bad or not bad. Or they might have a bunch of different output nodes, and they'll just be like, well, if the sum total of signals is more than X, then put it into box A. If it's less than X, put it into box B. Is everyone following this so far? Cool. Great. Yeah, see, built of neurons. Neural network neurons are not the same as brain neurons. Maybe we should stop appropriating terms from other fields where they actually do science. Yeah. So this is just what I was saying. It's on or off. Should I fire? In terms of should I fire, that's actually a really subtle question. And there are a bunch of different ways of answering that. These are words for you to look up later. Threshold is pretty straightforward in that, have I received more than X number of signals? If so, fire. It doesn't really care about where those signals come from, just have I received enough instructions? Sigmoid is, actually with the laser pointer I can kind of illustrate this. The probability of firing in a sigmoid model looks a little bit like this, where this like flat line is 0 probability, and in any case, it gets to a point where it's unlikely to fire, hits an inflection point, probability of firing goes way up, and that way you kind of add a certain amount of like non-determinism to your networks. And linear combination is just a case of, well, if you add all the signals up together, does it equal X? If so, fire. But there are a bunch of different flavors, and some of them are good for certain problems, but generally whatever is provided out of the box with your neural network framework should be fine. In terms of learning, okay, so you have your neural networks. This neural network, if someone else were to build this with just some kind of threshold for firing, it would be the same as everyone else's. And that's bad because it doesn't allow you to adopt it for whatever problem domain you're trying to work in, right? Which might be, is this GET request malicious? See, I managed to make it web app relevant. I was worried about that, to be honest. There's more web app stuff later, just about. What you have in each of these nodes is what's called a weighting. And so that weighting is just a multiplier you add to multiply your input signals with to affect how it interprets what it sees. Backpropagation is one way of tweaking those weightings to make it better suited for your data. Right. So what you do is you feed your training data into the model, into the beginning. You see what the output signal is. You compare that output signal to what it should have been. You take that difference and you use that to change the output node's weightings to make it closer to what it should have been. And then you take a look at what the subsequent nodes, like, well, the previous nodes downstream, upstream, it's backpropagation, sorry, I have to rework my flow, to see what those nodes should have fired, and so on until you get back to the input. And that way you kind of tweak the weightings to make it closer to how it should have been. Problem with that is you can change the weighting so it does perfectly on that one thing that you're testing on. But you don't want it to be really good at telling, yes, this one specific packet I've looked at is malicious. You want to make it more general purpose. And so you have to decide how big a change to the weighting do you want to do. If you make a really big change based on one individual piece of data, you can train faster, but you're less applicable to the wider world. And likewise, you can make small changes, so your training is really accurate, but it takes many more steps for it to start being performant for like a wide set of things. And it might just tell you that your neural network shape is wrong. How do you know what kind of neural network to use and how many nodes it should have and how many hidden layers you should have and all of that kind of stuff? I don't know. Nobody else does either. So you know that that genetic algorithm stuff I was talking about before? What people have done is they've built neural networks like randomly using genetic algorithms to then optimize neural network designs for specific problems. And it gets really meta really quickly. Or you could just use genetic algorithms to adjust like the initial weighting so that you can have like a more efficient training run. But it's not science yet. It's still very much magic. In terms of how you attack it, one thing, it depends. If you can affect the training data, so there are three different kinds of ways of training a neural network. One is what's called supervised learning, which is you have your training data. It's nicely categorized so that it knows what buckets it should be in, and then that backpropagation stuff works. There are other training methods that use unlabeled data and just let the neural network figure out what the different boxes should be. If you can affect the first kind and like inject training information that's wrong, then you're telling the machine lies, and machines believe lies. That's why pen testers have jobs, right? And so you can deliberately ruin someone's model by feeding it garbage. What you can also do is, if you have some kind of like oracle where you can tell how the model categorized your thing, your packet or your shellcode or whatever. What you can do is you can make semantic preserving transformations to the packet, so it still means the same thing, it still does the same thing, but it's different enough in structure that the neural network doesn't know what it is anymore. And they're kind of like the two main categories of attacking outside of like more traditional attacks to the infrastructure. Speaking of garbage, applications. Sorry, that was a lot bitchier than I was intending. So, because I thought the Nazi stuff was coming up. Anyway, so in terms of how you actually use this stuff, you can use it to detect malicious network traffic. Maybe someone is uploading payloads to your web portal. How do you know whether it's malicious or not if it doesn't trigger like a virus total signature? I know some people at Sheffield Hallam who have done like snort signatures based off neural networks, like using the neural networks to find snort sigs. I've seen people using it to like identify malware based on like behavior. One group I know of are using machine learning, and I can't get any more details out of them than that without signing an NDA, to identify malicious actors on a network. So it's you use it for intrusion detection, like that's a thing that they're doing in academia, but this company is doing it to, like, it's ignoring the initial intrusion and instead detecting people behaving suspiciously on your network. So it learns how your network works, and then it looks for nodes behaving in weird ways. But ultimately, machine learning is about taking an unknown bit of data and then putting it into a box and giving you some kind of like sorting information. You use it for classification problems. Classification problems like hunting Nazis, which I guess is the most interesting part of the talk. So if you weren't paying attention now, this is the bit you want to listen to. Just as like a caveat, I am going to be displaying Nazi propaganda on a giant screen. I don't like Nazis, and so there may be some swearing. I apologize. In terms of the group of people behind it, it's two really interesting, talented people and me. So we have the person who started it, Emily. She is she currently works as a threat hunter for an unnamed company. She used to be an intelligence officer for the NSA, worked for the CIA and the US Army, was their first like initial intrusion operator, like the first civilian initial intrusion operator for the US Army. Really talented person. Very much admire her. We have Ashanti. They are a Rust developer and rapper from Montreal. And they're just the coolest person. It's like they're painfully talented, but also really interesting, and it's kind of sickening. And then you have me. So what we do, Nemesis is what we're calling it. It's a tool for automatically finding white supremacist propaganda, which generally tends to be neo-Nazis and like alt-right trolls. It collects images automatically from Twitter. It uses machine learning to figure out what's in it and then categorize it appropriately. And it's made of a whole bunch of different parts. The first one is called Catch Me If You Can, which is a front end written in Rust. It looks at Twitter for badness based on keywords. One of our projects is to learn what keywords to look for as part of this process. Ashanti wrote this, and there are a bunch of different other collectors like finding images coming online gradually. We have the Nemesis model itself, which Emily trained. She painstakingly went through hundreds of images of Nazi propaganda, drew careful boxes over the things which were bad, and labeled them. And I can't think of a more soul-crushing job that someone would do for free. But there you are. She wrote a model in TensorFlow to do image recognition, trying to recognize this data which we've labeled and fed it. It's very extensible. So it's just like a generic image recognition model that she's tweaked. And currently we have like 25 different kinds of like symbols that we're recognizing. It works on video as well, which is quite cool. And it's really easy to add another like categorization label and then retrain it. The plumbing. This is where I come in. So Catch Me If You Can runs and gathers the image. We have the TensorFlow model for actually doing the classification, and we do some cross-referencing about the people who actually post the malicious images. And we figure out who is actually spreading this propaganda and do some mapping of hate networks and stuff like that. What I do is I take Catch Me If You Can, and I take the Nemesis model, and I make it so that it works together as like one contiguous system. As of like 3 days ago, it was a collection of Python and Bash scripts and cron jobs. It was really rusty. Now it's there's like a RabbitMQ instance in the middle of it, and Nemesis and Catch Me If You Can both publish messages and other things, and like read those messages, and it's coming to quite an exciting time. Because one of the things which you can do is you could be like, okay, well, we found a new image. Publish, we found an image. Nemesis reads that message and is like, okay, I'll classify it. It says, oh, this one has a confidence score of 98% that it's got a swastika in it. Other bits can read the message being like, this is a bad image, and be like, okay, so what other images has the person who posted this published in their last 200 tweets? Who are their mutuals on Twitter, and what images have they published? And then get those images, publish those to the queue, being like, I found a new image. That part of like doing the mutual hunting and stuff is another bit I wrote. So I said I was going to show white supremacist propaganda. Yeah, that's going to happen. I'm really sorry. Here we go. So here's a really easy one that we found. It's a swastika, and it's on a poster. I think this might have been Centerville in the US, Charlottesville, possibly, in the US. If that word means anything to anyone here, it should. Any case, it's really easy. It's really nice and clear. It's a little bit dark, but it's fine. Yeah, so who knows Roseanne? Roseanne Barr, comedian? Okay, so she's garbage, but she's also Jewish, and she did this photo shoot as part of like a thing for a satirical Jewish magazine. Machine learning models don't know the cultural context of the data that you're giving it. And so if you give your model data that's biased for cultural reasons or whatever, those biases will show up. If an image is like, it's offensive but deliberately so, your model isn't going to pick up on those social cues. That is another active area of research, but by people much smarter than me. Here's an advanced one. So here we have a swastika, but it doesn't look like the swastika here. It's just that vague shape. And yeah, it's fucking... I really dislike Nazis. But the fact that the model was able to pick this up is actually kind of impressive, at least to me. I can say that because I didn't produce the model. And here's another one. So this symbol is called a black sun. Right-wing death squads is an actual hashtag on Twitter. Don't go there, unless you're going to exercise your block button. But that symbol is supposed to be like black on a white background, and it's not supposed to have a... Is that like a Wolfenstein person? I'm not sure. In front of it. So it's clearly picking up on that like shape, that pattern. And here we go again. It's like that, you can kind of see what the image is supposed to look like, but here it's tilted and it's on fire and it's broken up a bit. It's not very clear. Size doesn't matter as far as this is concerned. You can see the tiny little KKK icon on this like really cool looking person right here. Ugh. Why do they always look like... Anyway. Yeah, like, they're...
Why is it focused on the logo?
Right, it's... it's focusing on the logo because it's trained on that symbol. So again, it can't tell you, well, this is, it'd be nice if we could train it, like, look for the giant douchebag wearing like a princess hat. I should get a princess hat. With like, I don't know. Anyway, yeah, we can focus on the iconography because that's at least relatively straightforward. And there's nothing that douchebags like more than advertising that they're part of like asshole club. So, yeah, good work. So this is an image. The alt-right is weird. So we found this swastika, but we missed the SS ruins. We missed like other swastikas. We missed a whole bunch of other stuff. We missed the really sinister gallons of milk just everywhere. Yeah. So there's this image is one of those things which we're going to put in our training set and tag. So one of the great things about running a project like this is you go looking for material that you classify. You can then so the way the model works is you draw a box around what it is you want it to learn. So I could, draw a box around like balaclavas or gallons of milk, but it's, yeah. But what we do want to do is we want to take the images that we've found, especially ones that it's got right but missed stuff, or things which it didn't get right because it's like a false negative. Because we keep track of all the images that we find, positive, negative, we just keep them into different places. Take those and then modify the model so that it keeps getting better. And ideally we'd like to automate this whole process, but it's a little bit difficult, like automated tagging of images. Because if we could automatically tag images, then we wouldn't need the model. Does that make sense? Yeah.
Sorry, what is the origin of this? Because to me it almost like falls into the like Roseanne camp.
Right, absolutely. The answer is I don't know. We have that information, but I don't remember what it is. It's in a database that we keep hold of.
But this would be the same. You said that when it comes to like artistic or
right.
photojournalism, for instance.
Sure, absolutely.
These aren't coming into your particular research.
True. Yeah. Someone posted this on Twitter, and it was associated with a keyword that we were looking for. It could well. I mean, that could.
I think it's a fascinating picture. That's all I'm saying.
It's hypnotizing. Swing and a miss. So it said that this was a swastika, this box down here at the bottom. In terms of like win-lose, this is a loss. Sorry, anyone who, yeah, anyway. In terms of this though, we're getting increasingly fewer misses, and we're getting much more wins. And this is something which like 3 transgender hackers put together in their spare time with 0 budget, 0 infrastructure. And you think of like, what could a tech company do with hundreds or thousands of engineers? We're dealing with like Twitter's rate limiting on their free API. Imagine what Twitter could do if they actually, cared about this kind of stuff. I'm not saying that Twitter tacitly supports white supremacy. I'm just saying that if they didn't, they could do something about it, and they're not. Hi.
Are they not doing anything about it, as you say? Because they
Not.
get millions of images a day.
Right.
And they get a lot of bad press when stuff gets out there. So they have,
Oh, sure.
hours of people manually look at this. But they must have some software doing this as well.
I am.
How do you sift the needle in the haystack?
Right. I believe they have, my understanding is they do have some automatic stuff. They also have an army of people who like find images and then report them. And that army of people are like us when we see garbage in our timeline and hit the report button. And then presumably they have another army of people. The industry of people who like look at reported content is horrifying. There's a recent article, I think, in Atlantic about the life of people who do this. In any case, it's really bad. we're doing reasonably at finding this stuff. Twitter could do a lot better, because they also have access to a giant corpus.
They apparently have to filter things differently for Germany in particular, and they do so in order to eliminate a lot of the people that they know to be Nazis.
But they don't.
Germany is self-governing, I think, so it's very much in terms of like it's very much the user. So if you see something and you report it, it's the user being like, is it under this law? Is it under this? Like, are you being abused?
But there are a whole bunch of accounts that just don't appear in German Twitter.
Yeah, so if you look at the JSON user objects, there's one that I think it's like restricted in Germany, which could just be probably Nazi, and it's set to true for a bunch of accounts that show up in my timeline. So they already know who the people are, and they don't do anything about it from most other places. Sigh. In any case, in terms of what we're going to do next, the automation is getting better, but it's still not great. We need a lot more data, but like manually tagging this stuff is really hard. Luckily, we're gathering it, and so that's probably a thing I'm going to be doing when I'm shortly unemployed. We're going to be using the data we've got to try and map out hate networks. There are a couple organizations like charities and stuff who are interested in this kind of information, but really what we want to do, ideally without publicizing Nazi propaganda too much, is convince social media groups to actually do something about the fucking Nazis, because they don't. They say they do, but it's not working. If you want to do this, because if you have like a good solid few weeks, you could probably do something like as good, if not better. What we're using is TensorFlow, but Keras is a really cool library that sits on top of TensorFlow and like makes the syntax a little bit nicer. This code defines a neural network. We have a densely connected set of nodes. They activate with this kind of mechanism for triggering. We have another layer of densely connected nodes, and we have a method for them to activate. And you could feed that data and it will classify it for you. It's not, like, understanding how that works on a theoretical level is pretty hard, but actually giving it a try really isn't. TensorFlow in particular have really good tutorials. It's right here. I would say that figuring out what the data that you give it should look like can be quite hard. But there are a couple of examples where they give you like input files that you point the model at, and that file format can be relatively easily reverse engineered. Like, it's a plain text file, but in terms of like what the columns look like. As like a summary, it's a huge field, and it only really works if you know what you're looking for. Like, you can tell when a solution is good, but you don't know how to get to the solution yourself. Maybe machine learning can work for you. If you're expecting to like gain insights about your data based on your machine learning model, you're going to have a hard time, because that is like a hard problem, like halting problem, hard problem. But you can still learn something just by looking at the data yourself. Most importantly though, you can do the thing. It's not that hard. If I can do it, then you guys can. And if you have any questions?
Fascinating stuff. In your adventures of doing this,
Okay.
have you come to the conclusion that the people guilty of it are not necessarily alt-right or Nazi groups, but agitators, as in nation states, according to or social discomfort?
I heard there was some kind of big press conference yesterday. No, anyway, in terms of whether or not, in terms of like who's responsible for this, the project's still in the early stages and we're trying to get the technology to work effectively. Turning it into actionable intelligence to then do something about is a little bit outside the scope of what we're doing. A lot of it, to say that it's nation states doing this kind of stuff would imply that the majority of people who are doing this aren't as racist as they appear, or rather it's misleading about the number of like racist people that there are. I think, in my personal opinion, the uncomfortable truth is, yes, there are nation states taking advantage of this stuff. yes, there are a load of garbage human beings out there who genuinely believe this.
I mean, but do you think it goes away if we get them offline? I think is the question. And I think that
Yeah.
like, with this applied with that sort of like social reasoning, I think the project could definitely go very far. It doesn't disappear, unfortunately, once it goes
Sure.
offline.
I really hope that that maybe we can make some kind of change with this, but I don't know. I'm scared as to where the world's going in general. This is getting very honest for like a technical talk. But like I'm a really bad shot and I can't run very fast. So if there was an actual war or something, I'm much better in a room doing intelligence gathering stuff like this. This is a way in which I can help, kind of. So we'll see. Any other questions?
Did you use just image recognition or also content or context of the user maybe? You can target or you can recognize
Oh, sure.
the author, but maybe if you have, I don't know, which of a list of hundreds of likes
It's,
of that image, you can maybe get.
see, this is interesting. One of the things which we're wanting to do, so currently it's just like object detection, image recognition. And that's pretty good. It can tell when things are, it can tell when something is an image, even if it's like slanted or even if it's a bit obscured or the lighting's bad or whatever. That kind of like contextual stuff is really important for weeding out false positives and also false negatives. So one of the things which we're looking at doing at some point is, because we have a bunch of different models that we're trying, like different neural network structures, what I'd like to do is, especially now that we have this like message-based system, is why bother using one model? Let's have 5, 10, whatever. Just like say we found a new image, see what like the all the models say. Maybe take into account minority reports about stuff. And then also we can use things like, okay, well, this person published that image. Are they already known to us because they've posted garbage before? Are they friends with people who have posted garbage before? Did they like some garbage that we've already seen? Figuring out who's liked stuff is actually really difficult with the API, but we're looking at ways around that. Yeah. In any case, context is super important, and it's something that we're actively trying to make better.
Just from another aesthetic point of view, I'm wondering if you looked at like Islamic extremism, for example, and wondering
Sure.
what sort of symbols was it more difficult to easier to
That's
hunt Nazis, for example?
that's a really interesting point. So, if any of you are inspired by this, I might be wrong, but I think the Home Office just did like a request for submissions for companies to build a tool like this, but for like Daesh and ISIS and IS and like other various flavors of that particular group or other affiliated groups operating in that kind of area. Because apparently they're really good at dealing with video, but they can't handle still images that well, which is really weird. So you could build something like this to target that kind of stuff. You would need to make a new training model, a new training data set, and maybe want to pick a different model to like do stuff. But the great thing about like white supremacist groups is that they really like to advertise their asshole club. They love symbols, they love regalia, they love really distinctive things that make them special. Special in a bad way, but you know, special nevertheless. And so I'm not an expert, so I can't say as far as like that part of the world is concerned. But to my knowledge, they don't have so many like distinctive symbols. Daesh being like the main outlier to that. But yeah, it's something which we have considered, and we know a few people operating in that space, but they don't want to talk about it publicly yet.
Another tech for terror, have you heard it?
Yeah, sounds good. Anyone else? Any questions? All right, well, if you do think of anything else, please feel free to reach out at either email or Twitter, and thank you very much for listening.